Okay, yes, we are ready. So, the name of our guest speaker is Mr. Abu Michael. Abu Michael holds a degree in electrical electronics engineering from Auchi Polytechnic. He furthered his knowledge with a course in fundamentals of basic electronics at the Georgia Institute of Technology and obtained a professional diploma in education from Adeniro Ogunsoya College of Education. He served as an engineering officer at the 321 Business and Electronic Institute of Technology, where he succeeded in building 4 inverters, a touch switch, an auto-off pumping machine, and has built different battery chargers for small appliances. Currently, he's a senior tutor in Seaside Heights Secondary School. So welcome with me, Mr. Abu Michael, as he takes up and starts his session. Mr. Abu Michael was my tutor, was my physics teacher in secondary school, and I'm so excited to be hosting you for this session. You're welcome, sir.
Uh, I don't know what to say. Good afternoon, everybody. Hope everybody can hear me. Yeah, good afternoon. Oh, sorry, it's evening, right? Good evening, everybody.
Good evening.
Good evening, sir.
Yeah, good evening. I'm happy to be in everybody's midst. Sincerely, I don't know what to say. I am taken aback by that introduction and everything. Hope I'm not too fast in my speech. If you think I'm fast, please tell me to slow down so that you can absorb whatever I'm saying. She has told me of this program a long time ago, so I will not waste time. I'll just start talking about it already. Okay. So I think we can start now, right?
Yes, sir.
Okay. So we want to know how to learn physics, but I have to give a brief a brief introduction of what physics is all about. Then hopefully, once you've seen what it entails, then we can quickly go to what is how we can study it. So physics is actually a science subject that studies matter in relation to energy. That's basically what physics does. Physics studies matter in relation to energy. I believe in one of your classes, you must have been taught that matter is anything that has mass and occupies space, right? Is that it? I'm not getting response. Is that what matter is? Anything that has mass and occupies space?
Yes, sir.
That's what physics is. Anything that has mass and occupies space. So
Yes,
if
sir.
you look very well, you'll find out that everything around us has mass. Everything has mass. The book, the pen, whatever, they all have mass. So it will mean that physics studies everything, but it studies them in relation to energy. Yeah, that's what physics does basically, studying matter. Now, a physicist is quite different from a biologist or a chemist. So how we view things is quite different, right? Now, a biologist, for example, a biologist might a biologist might, be concerned about the human anatomy, or the brain anatomy, whatever, any part of the human body. But if a physicist were to look at the human body, will be more concerned about the that energy that can be derived from it. For example, research tells us that the brain can produce 20 watts of energy, about 20 watts of energy. Now, for a biological component to produce that much power to light a bulb, that is the areas that we look at as physicists. Okay, so physics studies matter in relation to energy. It's studying basically everything that has mass, but with energy. I hope that is very, very, very clear. Uh, okay, I hope that's clear.
Yes, sir.
All right. Now, hope you know that we have a lot of careers that one can learn by studying physics. A lot of careers. All engineering can be, you can. do all engineering with physics, electrical, mechanical, civil, aeronautical, robotics, electrical electronics, mechanical electronics. Many schools we call that mechatronics. So you can learn all of that, or you can have all of those careers just by studying physics. You can be an astronomer, you can be a sound engineer, you can be a researcher, you can also be a teacher. When I say teacher, for example, I mean teacher in all categories: primary school, secondary school, a lecturer in the higher institution, and a professor in the higher institution. One can be a teacher of physics. That's a career in physics also. Now, what baffles me is that despite the fact that physics is not very difficult, a lot of people do have concern with physics. And this forum is just to help us see how we can learn it and make it like very, very easy for us. So I'll be saying some things very quickly. I'll be saying some things very quickly, then I will open the floor for question. Okay. So let's see. Basically, physics has two different areas, or let me say three different areas. One of it is the calculation part, the part that has to do with calculation. Another part is the part that has to do with the concept. Then lastly, another part is the part that has to do with the practical. So we have three parts in physics: the calculation part, the concepts or the principles or theorems of physics. Then we have practicals in physics that helps us to understand the concept very well. So if you are very conversant with the principles and you are very conversant with solving questions and you're very conversant with practicals also, then you'll be a very good physics student. All right, before I dive in a lot again, let me quickly talk about the calculation part. I think that part is very simple. Uh, Many people have issues with calculation. I don't know why, but the calculation part, I think, if you ask me, is one of the simplest parts in physics, because all you need is just simple maths principle and a little understanding of English. You know, you just need to understand English or whatever subject the question is you are using to read your physics subject. But in Nigeria here, I believe most of us, if not everybody, we read our test in English. So you need a good understanding of English. Not only that, uh, you need to know simple maths concepts, like substitution, for example, like algebraic equation, for example, and like a change of subject or formula, for example. These are the three formulas that needs to be, these are the three stuff that you need in doing your calculation. Change of subject, one, algebraic equations, two, and substitution, three. That's all you need for your calculation. So if I tell you V, voltage, is equal to current times resistance, that's the formula, Ohm's law, right? V is equal to IR. So you know the formula now. And I tell you that voltage is 10 volts. And I tell you that resistance is 2 ohms. Now you will find out that to get the current will not be very hard. Since you have a very good understanding of substitution and you have a very good understanding of change of subject of formula, you will find yourself writing 10 is equal to I times 2. Then on the next line, you find yourself writing 10 is equal to 2I. Then finally, you will find yourself dividing both sides by 2. Then you get a current of 5 amps. You see? So I hope everybody is with me.
Yes, sir.
Please, if I have said something that sounds very strange to you, you can please notify me so that I can break it down, then I continue. Like I was saying that the calculation part of physics is actually very, very simple. And if you can do substitution, change of subject, and you know some algebraic equation generally, then the calculation part is simple. And that's about it. Now, the concept part, when we say concept, Concept means that we are talking about the principles of physics. The principles of physics. Now, a lot of people have issues with the principles of physics, and very shortly, I will be telling you why people have problem with the principles, where even after they have read their books over and over again, it looks as if the thing is not getting very clear. I would like to say that physics has many branches, and these different branches, you have different principles that are guiding these different branches. We have a part of physics that is called optics. We have a part of physics that is called electronics. We have a part of physics that is nuclear and atomic physics. We have a part of physics that is classical physics. We have a part of physics that is Newtonian physics. We have a part of physics that is just heat and temperature. So you now find out that we have different aspects of physics, and these different aspects of physics are governed by different principles. So the classical physics, for example, gives us general principles in physics. Aha. But when we start diving into nuclear physics, we start diving into atomic physics, you start talking about quantum physics, you now find out that there's a little bit of variation with the principles. But the basic principles are gotten from your classical physics. And if you have a good knowledge of your basic principles, you now find out that physics is not very, very hard. I'll just throw an example before I start discussing the problems, and I'll tell you how I personally study physics. Then you can throw your question at me so that I can give you your answer. I'll be trusting that I'll be able to answer all questions very, very quickly. Let me give you a short example. If you take a stone and you throw a stone up, for example, will the stone continue to go up? If you throw
No,
a stone up, will the stone continue to go upward?
no, sir.
The stone will not continue to go upward because it will get to a
Gravity.
point in the sky when we get when we
No,
get
sir.
get a point there, then the stone will start falling back. All right. A lot of things are the principle behind that will be the principle of motion, right?
Yes, sir.
So if you look very well again, you find out that when you throw a stone up, it looks as if the speed is decreasing as it's getting high, up, up, up. The speed will be decreasing. So you will not find it very difficult to understand that the final speed of the stone is going to be 0, and the initial speed of the stone is going to have a value. Now, in the class, teachers, many times you hear them using initial velocity and final velocity. But in physics, it appears that speed and velocity are actually used synonymously. Their difference is just very, very small. And that is where your teacher will be talking about scalar quantities and vector quantities. But I'm not here to talk about all of that. I'm just trying to explain what concept is. That every aspect of physics have governing principles,
Okay, sir.
governing phenomena that they work with. Somebody called my attention. I thought I heard "sa" or something. All right. Then in understanding concept also, the physicist mind you must have a very wide imaginative mind. Your mind must be very, very broad. If you can brood over a concept for a long time, you now find out that it is getting very, very, very clear. So as a physicist, one have to be able to, your power of imagination should be high enough to capture everything that is being said. Then lastly, one should be very good with the practicals. And it is that aspect of physics that we are lagging in primary school, secondary school, even the higher institutions. That practical part is like 0. Even the practicals they do, sorry to say, even the practicals they do for WAEC, that's not that's not practical that can advance the cause of the nation. It's just something to if you ask me, I think it's just wasting one's time, because practical really should be able to solve real life problems. Like real life problems, practical should be able to give us good ideas of how to solve them. And if practical is not doing all of that, then we are not there yet. If we continue doing what we are doing in the laboratory, SS3, SS2, SS1, then there's no way we are going to advance the cause of this nation technologically. Well, that be it. So I want to now share to everybody how I personally look at physics and how I study and how I approach it. And that way it becomes very, very easy. So you can all listen now. Okay. I saw that somebody left the group. I don't know why, so that's why I paused. I wanted to be sure of something. Okay, shall we? Let me continue. Personally, if I want to study physics, I like to look at it. Or somebody just raised the hand. Yes, I'm with you, Nkechi. Baba Wale Nkechi, I'm with you. You want to say something?
No, sir.
I saw your hand raised up, so I thought maybe you wanted to say something. Okay, unlike other subjects, probably arts and many subjects, if you will read physics, you should, I will advise that you should take your physics studies in a very, very quiet environment. Now, science subjects generally are not subjects that requires distraction. You should read in a quiet environment. If your morning time is your quiet time, then your morning time is the best time to read. If your night time is the quiet time, then your night time is the best time to read. If your library is quiet enough, then your library time is the best time to read. Now, as a science person or as a physics student, I would not advise anybody or any physicist to read in a noisy environment. Now, the art student can try that. Those guys that draw, that paint, they can be playing music while they are, while they are drawing. Probably the music has a way of inspiring them. But if you are a learner of physics, you are just starting, I do not expect that you should be reading or studying in a very noisy place, okay? You should be studying in a quiet place. So it's possible that probably when you study, you do get interjections, interference from different corners. After this time, it should stop. You should read in a place that is very quiet so that you can assimilate very well. So that's my first strategy. I read in a quiet place. I read when a lot of interferences have been reduced to the minimum. So I read in the morning time, then I read at night. So then if nobody's at home in my house, then I can take my books and read. And if I'm sure my partner or anybody in the house will not give me trouble while I'm reading, they know when I'm reading, everywhere should be quiet, then I can do that. Okay. So the number one thing is, if you want to read physics, you want to study physics and learn it very well, you should read in a quiet environment. I hope that is taken.
Yes, sir.
Okay, so that's the first one. Then the second thing I observe with learning physics is that many times when people read or study physics, they come across words that they are not very familiar with. And they don't do anything to find out what that word is. Now, let me give you a shocker, everybody. It took me a long time to know what magnitude is. Magnitude. Now, all through my secondary school, till I get to the higher institution, you will not believe I don't know what magnitude is. So I was just cramming whatever the teacher have said. The scalar quantity is a quantity that has magnitude but no direction. Now that word magnitude, I have no idea what it is. I only got to know about magnitude in the higher institution. It took me like 4 or 5 years after SS1 to know what magnitude is. So when you come across words in physics or words in physics that you're not familiar with, you should pause. You should find out what that word is. Now, it will interest you to know that magnitude just means number value. So when you say a scalar quantity is a quantity that has magnitude, you're just saying a scalar quantity is a quantity that has number value, a quantity that has size, that has number value, but no direction. It's as simple as that. Okay, so find out what a word is if you come across such, and that is where my third strategy will come out from. I am actually a fan of synonyms in English. Remember, when I was talking about physics earlier on in the calculation section, I said you will need a good knowledge of English, mathematics, to be able to do your calculation. You will also need a good knowledge of English to be able to understand concepts. Okay, so this is where your synonyms comes in. Synonyms. I believe in English, you know what synonyms means, right?
Yes, sir.
Oh,
Sir.
perfect, perfect. Words that have similar meanings or something. Okay, so
Yes.
let me give you an example where I can just use a synonym. I will be stating Newton's first law of motion. An object will continue in its present state of rest. Now, if you are used to Nigerian textbook, it will now look as if most authors have a general meeting, and many times they have to say a law, state a law the same way. Some of these authors are not even they are not even English authors. Albert Einstein, for example. Albert Einstein is not an English person. So when he stated his law of relativity, it wasn't English he used in stating it. Albert Einstein stated those principles in his native language. So what we have in our textbooks are actually interpretations of what those guys said. But it now appears that many times when we state these laws, even in exams, you find us stating it as the textbook have said it, which is good. I will talk about that later. I don't think the time will allow me to go that deep, but I will just try. Okay. So if back to the first law, an object will continue in its present state of rest. Now, if you check the word, if you look at that word present by contextually, you will find that present also means its current state of rest. An object will remain in its current state of rest, except an external force makes it do otherwise. I just stated first law, and I did not even state it the way it was stated in the book. All right. So if you are a master of synonyms, you know how to use synonyms very well. You now find out that those big words, you find that you have ability to break them down and make it very, very simple. I hope that is a simple enough. So that is what that is how I attack physics. When you look at all of these things, you read in a quiet environment, you are you pay attention to your synonyms. Then anytime you find a word that is not okay, you go and find out the meaning. Then you now find out that you are having a better understanding of the concept. Then there's one more thing I do. Sometimes I use what they call mnemonics and songs. I give you an example. I'll give you an example. I'll attend to your question maybe after this one. Uh, in physics, we have 7 fundamental quantities. They are mass, current, and there are 7 of them. So I was studying with one of my students, and we came up with something. So instead of me trying to recall the 7 every time, I came up with a word, and the word I came up with is callmat. Callmatt. Call space mat. So if I remember callmat, then I can call all the fundamental quantities. So my C will be current, my A will be amount of substance, my L will be length, my second L will be luminous intensity, my MA will be mass, then my T will be time, and the last T will be temperature. So I use mnemonics sometimes to aid my understanding. Then at times I turn concepts into songs and I sing them, and now become part of me. And because I have sang them over time and I've meditated on it over time, I have used my power of imagination on it over time, then the concept become very simpler. If you follow these 4 things I said, you now find out that your physics is not as hard as you thought it is. No, it's actually simple. Then the practical part, like I said, our schools are not well equipped to give us the practical knowledge that we need. So my advice in that section would be that if you're a physics person and you want to be practically inclined, so shortly after your secondary school, or if you're in the higher institution, what you should do is that you should look for a place where you can grab practical knowledge. We have a lot of places around where they do practical stuff, like electronics, for example. You learn how to use your soldering iron, not an electronic workshop. Oh, please don't get me wrong. You are different from those guys that are by the roadside. So I'm not referring to a workshop on the roadside. There are institutions, good institutions. I can even recommend one. I can recommend quite a lot, for 1, 2, 3 for you, where you can learn, have good practical knowledge of electronics, where you can learn IC programming, where you can learn principles of basic electronics. That is, if you are interested in that electronics aspect of physics. Then because you are doing those parts, you now find out that other concepts in physics, they are becoming clearer, because if you can attack one part of physics very well, you now find out that somehow you have entered into other areas in physics. I think I should stop now. I have spoken for like 26, 28 minutes. I think I should now calm down and probably hear what some of you have to tell me. So I will just listen to what you want to say, then I will give you answers to the best of my ability. I'm all ears. If you have any question you want to ask me, I am ready to say something.
Thank you very much, sir. I really appreciate that. So now, if you have questions, this is the time to ask. If you have any concerns, anything you'd like to ask, okay. Yeah, you can go ahead. I think.
Is as if Rose want to say something?
Excuse me, sir. Sir, please, can you mention some places, some electronic workshops?
Okay. I have a colleague in Ekpe there, in town there. If you go online, if you Google it, it's known. It's a very known place in Nigeria here. It is called OPSTEP, Upstep Engineering. It's my colleague, it's my friend, Upstep Engineering. You can Google it, you will see it pop up. You go to Facebook, you can see it pop up. OP space STEP space engineering. Then that's one institute that you can learn a lot of things in electronics. Not only will you learn soldering, not only will you learn the basic components in electronics, like what a resistor really is, you'll be seeing it live. Not then you know what it does, apart from what has been said in class. You will know different things you can do to a resistor, your capacitor. You'll be able to build simple circuits using resistors, capacitors. Then you start talking about semiconductors, like diodes, like transistors, like ICs. And when you now leave that part, analog electronics, you now find yourself discussing digital electronics. Then shortly after that time, you now find yourself discussing programming in electronics. Now, it is that programming in electronics that is now integrated into this your computer scene that you see currently. So physics is very broad. It has something to do with communication. It has something to do with medicine. It has a lot of applications, sincerely. So in that institute, you can learn all of that. All of that. There is another one. The engineer name is Engineer Richard. He stays in one part of Lagos called towards Badagry. Badagry is, I don't know, probably maybe your place is far from Badagry. Then we have like 2 other places in Lagos. I can maybe get their names for you, and I will send them to Bogo through you, so that you can have their names. So I just told you of 2. One, Upstep Engineering, then one in Badagry. That one is supervised by an engineer called Engineer Richard. He has been practicing practical electronics for the past 16 years or thereabouts. So so that's just a few. Now, the one I would have told you of, where I learned 321, where I was an engineering officer, the owner of that establishment is now interested in something else. He has moved on to bigger projects, working in Nestle, working for the federal government, trying to travel abroad and come back. So He doesn't have an office that is open right now for such stuff. Otherwise, I would have recommended that place for you. That was where I worked before. That was what the host read out in the profile when she said I was an engineering officer in 321 Business and Electronic Institute of Technology.
Okay, sir. Thank you.
You're welcome. Is that only what you want to know, where you can learn the electronics things?
Yes, sir.
Okay.
Are there other questions? Marianne, do you have a question?
That magnitude that he explained, he said magnitude means number, value, and sizes. So, number, value, and size. You should please come down.
I should break it down.
Yes, number, value.
All right. Let me explain what number, value, and or size actually means. Now, if I tell you that the force applied on an object is 25 Newton, for example. Now, that 25 Newton that I mentioned, okay, so 25 Newton is the number value of the force that I just talked about. So that's 25 Newton, which is the number value, is the magnitude of the force. Oh, you get it now?
Yes,
If
sir.
I ask
Thank
you
you,
what's
sir.
your shoe size, you'll be telling me probably your shoe size is maybe 37. You can be saying your shoe size is 45, or you can be saying your shoe size is 22. So you are telling me if shoe size is a quantity, then 35 or 47 that you have mentioned is the magnitude of your shoe size. If I ask you how much did you use to buy your PS5, for example, and you're telling me I bought my PS5 for 120,000. That 120,000 you just mentioned will now be the magnitude of the price of your PS5. So the number you attach to a quantity is the magnitude of the quantity. So if anytime you see number in your physics question, that number itself is the magnitude. So if I tell you find the magnitude of the force, it's as simple as saying find the force. You get it? It's as
Yes.
simple as that. Does it make sense what I just told you?
Yes, sir.
All right. Okay. Thank you very much, Miriam. So if you hear a current of 2 ampere flows through an electronic circuit, that 2 ampere that was mentioned with current, the 2 ampere is the number value of the current. The 2 ampere is the magnitude of the current. Okay.
Yes, sir.
All right. You're welcome. Thank you very much.
Okay, sir.
Are there other questions? Please, let's ask questions.
I thought I would be getting. Okay, somebody just raised the hand. That's it. Mr. Kinghart. Mr. Kinghart, I'm with you.
Please, can you repeat the meaning of call mat?
Hallmark. Okay. When I said Hallmark, you know, probably in SS1 or SS, no, it's SS1. It's SS1. In SS1, you were taught fundamental quantities. You were taught derived quantities, right? Okay, so you were taught
Yes,
that
sir.
the fundamental quantities are 7. Now that call math, what it means is this: call, C-A-L-L, then math, M-A-T-T. Okay, so the C means current. C is current. The A is amount of substance. Then the L is length. Am I too fast?
No, sir.
Okay, so C is current, A is amount of substance, L is length. Then the second L will be luminous intensity. Okay, so that's call. Then the mass, MA, I'm taking MA together. MA is mass. Then T is time, and the last T is temperature. So if I know call mass, then I can call all the fundamental quantities.
Okay, sir. Thank you, sir.
You're welcome, my friend. Thank you very much.
Yes, sir.
Thank you very much, sir. Are there other questions? You can type them in the chat or just go ahead.
Okay. It looks as if we don't have a lot of questions to ask. Well, somebody was trying to find out what centripetal force and centrifugal force is all about. Is the person here now? I don't know if the person is here. And somebody wanted to know about electronics, a lot of electronics. Is the person here also? Somebody
Yes,
wanted to know about wave. Who is the person that wanted to know about electronics?
me, Marianne.
Marianne. Okay. Who is the person that wanted to know about centripetal force and centrifugal force? So that I will not waste time, I will just concentrate on the people that are here so that I'll be able to answer the questions. And if you still have something to tell me, my ears are
Me,
still
sir.
open. Okay, I want to hear you. What's the question, please?
Like, I need to understand what they mean.
What?
Centrifugal force.
Okay, and the centripetal force. All right. So when you study physics, you may have come across centripetal force and centrifugal force. Now, let me quickly say something. Centripetal force is not like a type of force, okay? And centrifugal force is not, when we mention types of forces, now we only have two types of forces. The first one is a contact force, and the second one is a non-contact force, okay? Contact force, non-contact force. Your contact force will be referring to your push, to be referring to your pull, it will be referring to friction, it will be referring to reaction, it will be referring to tension. Those are contact forces. And when we say non-contact forces or force field, we'll be referring to your electrical force, gravitational force. All of those forces are non-contact forces. Magnetic force, non-contact force. So, but when I say centripetal force and centrifugal force, you almost start thinking that it's part of the type of force. So let me explain. Your centripetal force is that force that is like an inward force, a force that acts towards the center of something. As simple as that. I don't want to make it complicated. This is a forum and we have quite a lot of people. I don't want you to feel like we're in a class. Centripetal force is a force that acts towards the center of something. While centrifugal force is a force that acts away from your centripetal force. So I'll just use the Earth as an example. The sun, according to science, is in the middle of the galaxy. The planets are rotating around the sun. So the force that connects the Earth, or the force that pulls the Earth to the sun, is a centripetal force. Now, the force that is trying to pull the Earth away from the sun is a centrifugal force. Now, according to physics principle, these two forces are always the same thing. They are balanced. They are balanced pair of forces. If by chance, if by mistake, something happens and your centripetal force is higher than your centrifugal force, there'll be trouble. And if your centrifugal force is higher than your centripetal force, there'll be trouble also. So it now appears that the centripetal force that connects the earth to the sun is actually your gravitational force. So you now see that it's just a name that refers to all forces that moves towards the center of something. Why centrifugal force is just a name that refers to all forces that moves away from the center of something. I think that's a very simple way of explaining it. At King's Heart, you raised your hand. I saw it. You wanted to say something. Rosie, did I answer your question?
Yes, sir.
Okay, thank you very much. King's Heart, what do you want to say? I'm with you.
Okay, sir. So you said centrifugal force is a force that acts away from the words.
Okay, it acts away from the center. It's acts away from the center of something. Let's leave it like that. I wish you can see. Maybe I'm trying to do a kind of demonstration, but I cannot do all the demonstrations I would have loved to. Centrifugal force is a force that acts away from the center of an object, while centripetal force is a force that acts towards the center of an object. That's just a simple way of looking at it. And if, as a physics student, you look at things from the simple perspective, you now start having a better way of expressing yourself. You don't have to make it very hard. You can start using those simple explanations. And before you know it, you can now give an extensive explanation of what it's all about. Okay, I think that's better. Okay, thank you. Thank you, Kingsley. You are still raising your hand, Kingsley.
Okay, sir. Thank you, sir.
Okay.
No, I'm not using my like. Sorry.
Okay. I saw it raised up. When we came online today, I heard the name Oladipupo. Is Oladipupo online still?
Yes, sir.
All right. Hope you are learning something, because I'm trying my best to see that after this session, you don't see physics as difficult. If you follow those strategy, you
Yes,
read in a
sir.
quiet environment. When you don't understand a word, you look for it. If you use a lot of synonyms, mnemonics, and try to make a song out of what you learn 100% of the time. Let me share something else I do also, guys. Time will run out. After I've read a topic in physics, what I do sometimes is I take motion. So let's say I'm reading sound, wave, anything. After reading wave, then in my book I will ask myself what is a wave, gap for the answer. Then if I read again, there are two types of wave. Then I go back to my book and write how many types of waves do we have. Then I go back to my book, I give space, I write name them. So as I read the first time, then I read to generate the question. Then I cover my book. Then I start answering the questions that I've just asked myself without looking at the book. Now there are times you will find out that you did not get it very well. You now go back again to the book to find out how it was said. Where did you miss it and all that. If you do that also, that is a very good strategy to learning physics. That one I use it a lot. I still use it now. I have a lot of books. I ask myself a lot of questions every time, and I provide answers to those questions after I've read. That is how I've kept myself in shape for a very long time. Okay.
Thank you very much, sir. So would you still be covering the little of the electronics parts that Marianne talked about?
Marianne, you wanted to know about electronics. Now, electronics is actually very broad. So electronics is a part of physics, but that part of physics, I tell you, is broad. Because if you look around you, you find out that you have a lot of electronic appliances. Please, it is important to know that electronic appliances are different from electrical appliances. Your electric iron is an electrical appliance, but your phone charger, is an electronic appliance. Okay. So they are quite different. Your television is an electronic appliance. Your radio, your TV, your radio, your MP3, your MP4, name them electronic appliance. So my Rosie, if you want to be vast in electronics, you have to start from the basics. Now you have to know what passive components are. You have to know what active components are. So your first step in being a guru in electronics is knowing the basic components and how to use them. Then how to use them in particular design and what they do. So let me quickly tell you about those basic components. You have to know what a resistor is. A resistor is a basic component in physics, in electronics. You have to know what a capacitor is. You have to know what a resistor, capacitor, those two are two passive components that you should know about. You have to know what a transistor is, right? Then you have to know how to use them. You have to know how to read the value of a resistor. If you see a resistor, can you tell the value? Is it 10 ohms? Is it 20 ohms? Is it 40 ohms? In a practical class, you'll be taught how to recognize the value of a resistor by looking at the colors around it. Just by looking at the color, you just tell the value. Now, you can never learn that in school, except the school is taking electronics. Okay? So if you want to be vast in electronics, it is first thing first, you start from the basic components, which are resistors, then your capacitors, your inductors, your transistors. How to use them, what do they do? If you know what they do, how they use them, you now find yourself trying to put one or two together. And before you know it, you are designing, you are doing your first design already. Yeah, yeah. So for the electronics section, that's the first part. Then if you become a guru in that part, then you'll be looking at other parts like building an amplifier. That is, you are now diving deep, using transistor, building an amplifier. Then you now start learning how to use an IC. An IC is called integrated circuit, a small chip. One of the chips you'll be learning how to use, you can go and Google that also. It's called the 555 timer. The 555 timer is the craziest of all chips in electronics. You find out that you can, if you learn how to use the 555 timer very well, you know it, you will start learning how to use other components like 7805, like LM741, all your op amp, LM324. You start learning your 556. You just start learning how to use all of them, and before you know it, you are very good at design. You understand a lot of concepts. You can now from there go into IC programming. Your IC programming is somewhat related to coding, because in electronics, when you do IC programming, you are programming to make something work electronically. But your coding is a little bit vast. It may not be electronically inclined. It could be coding to build a game, right? But you'll be building this game in an electronic device like an Android phone. Well, that's another branch of physics which is still very, very okay. So Rosie, that is how wide electronics is. I cannot even discuss resistors in 30 minutes. Yeah. I cannot discuss resistors in 30 minutes. Much more a capacitor, much more a transistor, much more 555 timer, much more an inverter, much more an amplifier. No. But that's basically what it's all about. I hope you got something from this session.
Yes, sir.
Thank you, Miriam. And thank you, Rosie.
Your hands were up, King Zat.
King Zat, you wanted to say something?
Yes, sir. So, sir, what's the meaning of IC?
IC means integrated circuit. Integrated circuit. Maybe let me see if I can get you. Let me show you if I'm coming. Just give me a couple of minutes. I'll get you a nice.
Okay, you also have a question.
I hope you'll be able to see it. I have something in my hand. It's a small box. If you look at it very well, I have some stuff inside the small box. Okay, I just opened it. I will bring out some stuff. Maybe I'll bring like 3. They all have different names. So I will try and put it on the screen. Can you see that?
Yes, sir.
This is an IC, integrated circuit. It has a lot of pins. This one have some pins here, like about 8 on one side, then it has like 8 on another side. So when you open some maybe stabilizer, you open some inverters, you find this kind of black stuff inside. Now inside this IC, we have a lot of transistors, resistors inside. That's why it's called IC. Integrated. All the resistors, capacitors, inductors have been joined. They have been made so small. They now bond it inside this one. They now put it inside this thing. So this small thing that you're seeing can do quite a lot of things. This was how your computer started, your third generation computer. Instead of them using all those big tubes, they started using something like this IC transistors. That's how that is why it's getting smaller. It's like a computer. Even your phone, with your hand, you can hold it and do stuff. Hope you've gotten something. That's an IC.
Okay, yes, sir. Thank you, sir.
You're welcome, my friend.
Rosie, do you still have a question?
Okay, yes, sir. Kaitochi is name. How can you differentiate between an electrical and an electronic device?
Oh, wow. Rose, your questions are awesome.
Sir,
Please.
please, my name is Kaitochi.
Your name is what?
Kaitochi.
Kaitochi. I love your questions. Your questions are great. Now, this is actually the difference. Now, electrical appliances, they actually use AC. AC means alternating current. Then electronic appliances, they produce DC. They produce DC. Sharon Modi, I'm sorry I screamed.
So I should get the call.
I'm sorry I screamed. Rosie, I'm so sorry. That name is a very familiar name. So the thing just came like a flash. I'm so sorry I screamed. The host, please, Sharon Modi, I don't know if we can have Sharon Modi's contact. Let me answer Karikochi. Sorry if I didn't get the name. Kaitochi. So your electrical appliances, they use AC, right? Your electronic appliances, they produce DC. Now your electrical appliances, when I say AC is the voltage that comes directly from your generator, that comes, the one that people call NEPA, and you can connect it directly to NEPA. It uses that voltage directly, like your electric fan, for example. Your electric fan uses that voltage directly. But your charger, even though it appears you are connecting it to your wall socket, you find out that your charger has an extension. I'm coming. I have a charger very quickly. Let me quickly show you that. Just give me a moment. Okay, so back. This is a charger. Now you connect these 2 points, this point and this point. You connect it to your wall socket. Now, when you connect it to your wall socket, you are connecting it to AC, right? You are connecting this part to AC. Okay. Now, if you check out this other part, this wire part, what happened here is after you connected it to AC, there are some stuff inside the charger.
Please, can you mute? Is it going?
Okay, so there are some stuff inside the charger that converts the AC that has come here, that converts it to DC, and it travels along this cable. So the voltage that travels along this cable, that charges your phone, that charges your laptop, that charges your top, that charges your fan, that voltage is DC. Okay, so that's one difference between electrical appliances and electronic appliances. Then electrical appliances, they consume a lot of power.
Please, Kings, mute your.
Okay, thank you, King, for muting that. Electrical appliances they use a lot of electrical power, while electronic appliances use little electrical power. So as small as this charger is, you might find that it's just maybe 3 watts or 5 watts. Your electric fan is like 120 watts. Your electric iron is 1,500 watts. Some of them are 2,000 watts. It consumes a lot of electric power. Your air condition is an electrical appliance. Some of it 5,000 watts. So that's why you find that houses that have a lot of electrical appliances, they pay a lot of money for electrical bill, for their NEPA bill or for their PHCM bill. But for those guys that are using a lot of electronic appliances, you find out that even though they have so much, they are paying so little, because the power consumption of electronic appliances are very, very small. Like your charger, like your rechargeable fan is an electronic appliance. This one, I'm coming. I don't know if you can see. If you can see, this fan is an electronic appliance. Okay, but the fan that is up in your house, the one that is on the ceiling, is an electrical appliance. Your pumping machine, the one that pumps water into the tank, it's an electrical appliance. Okay, I hope that one is clear.
Yes, sir. Thank you, sir.
You're welcome.
Okay, so we'll take, if there's any other question, that will be the last. Is there any other question? Okay. So in the absence of other questions, I'll just quickly summarize some of the things that Mr. Abu has said. He mentioned five ways that you can learn physics effectively, 5 ways that he personally studies physics. And if you're following, I just want to know, okay, if you're following. So he mentioned 5 of them. First of all, am I correct or wrong? Am I right or wrong?
You are right.
Oh, really? Okay. So what's the first one? In no particular order. So what's the first one?
Quiet environment.
Exactly. Thank you. Can you help us with the second one? Carrie, I didn't get your name actually. If you can type it so that I'll pronounce it right. But can you help us with the second one?
Okay, using synonyms.
Yes, synonyms. Third one from King's Heart. Is King's Heart still here?
Using mnemonics.
Yes, mnemonics and songs also. Okay, so there's 2 more. In case you are still with us.
Yes, ma'am.
So what was
Kaikuchi.
Can you give us? Okay, Kings, please mute your cursing and echo. Okay. Yeah, so in Nkechi, I was asking if you can give us one of the strategies that Mr. Abu talked about.
Yes, ma'am.
We've mentioned 3 already, so which one did you pick out?
Okay, ma'am. After reading, take a book and ask questions from what you have read.
Yes, that was the last one he said. And so what's there's one more. Anybody can just say that. Who will get the finals?
Checking for words that you don't know.
Awesome. So that's to say that you were following and you've learned 1 or 2 things from this session. Thank you very much for joining this session. He also mentioned that for you to understand physics, you need to have a very imaginative mind, right? You have to harness the power of imagination, and that's something that's like cuts across learning in general. You need to be able to imagine things. Don't just you want to just cram what your teacher gives you give it word for word and things like that. Try to imagine. And when he was teaching, I was just remembering how I when I was like, it got to that period of SS2, SS3, I had to get a special book. I think my parents got it from me from the roadside, all of these people that sell books, written by like not Nigerian book, right? And that book made it talked about physics. There was one for chemistry and other subjects, but the one for physics, what I noticed about it, or what I was remembering about it that made learning so easy, was I had a lot of colors, it had a lot of highlighting, it had a lot of drawings, illustrations that made it easy to absorb some of these concepts that looks abstract, you understand? And so that book, it was even like drawing book. Imagine physics and chemistry presenting it like something that's so simple, and it's still like some of these advanced things that we talk about. So that book, in fact, was one of my favorite book at that time. And I was just remembering that when you mentioned the power of imagination. So that's something that you really want to, I'm going to use it to your to the best, because you keep studying throughout, not just in secondary school, keep studying even after the university, you keep studying. And so being able to imagine things would really help you in your study. Does King guys want to say something? Your hands are raised.
Yes, ma. So I forgot to ask, what's the meaning of DC?
Direct current. Direct current.
Okay.
Yes. So thank you very much, Mr. Abu, for this session. Really appreciate it. Thank you for your time. Thank you for accepting this invitation. Thank you for, coming up and having this session. When I posted this session on LinkedIn, the first statement I started with was that physics is a subject that I personally do not like physics. Not for any reason, but just because I loved chemistry more. Like chemistry was what was in my mind. I wanted to study chemical engineering. I wanted to just do chemistry stuff, right? So I didn't even like physics. Not that I didn't understand it or anything. When I got to school, starting from SS1, the way you started taking physics made me like it. And then chemistry that I liked, I started hating it. But now I like it back, Sha. So thank you very much, sir, for being a great tutor and for the awesome work that you are doing. Thank you very much.
Thank you very much, Mr. Abu.
Yeah, thank you. Kaitochi,
It's
well done.
Kaito-
Please,
it's
lastly,
Kaitochi's mother. Thank you very much.
Yeah, well done, Katochi. Lastly, do not use one book, one textbook. You can use like 3, 4 textbook. Read the same topic from 3, 4 textbook. It will help a lot also. I do that too.
Also, okay, so
Yeah,
we'll be
thank you,
ending.
everybody. Thank you so much,
Now.
everybody.
Thank you,
Thank
everyone.
you.
Good night. Can join us.
Yes, Umago, thank you very
Good night.
much. Oh. I
Thank
appreciate you.
Thank you.
All
So
right.
follow us on our pages at Gifted Brain Academy for more updates on sessions like this. Bye, everyone.
Yeah.
Bye,
God
ma.
bless you.
Bye, ma.
Bye.
Bye, ma.
Bye, sir.
Bye, ma.